Find the derivative of each of these functions. The derivative here, f prime of x, is just equal to 2x. This one here, derivative of f prime of x is also 2x. This here is x squared plus 1,000. Well, derivative is still 2x because the derivative of any of these constants is 0. So what's the antiderivative of 2x? So the general solution, this is what we call the general solution. The antiderivative of 2x is f of x equals x squared plus c, because no matter what this constant is, if you take the derivative, you're going to end up at a 2x. If there's an actual number here, like a plus 1, we call that a particular solution. Integrals without a boundary, without a lower and without a upper bound, are called indefinite integrals. Indefinite integrals. In the past, we've been working with definite integrals where the boundaries are given for the area under a curve. Now we're going to work with indefinite integrals, which just means we are finding an antiderivative as a general solution. So here's a couple formulas. Again, there's a lot of rules we're remembering now. So the integral of e dx, the indefinite integral of e to the x is just e to the x plus c, because the derivative of e dx is just e to the x, derivative of c is just 0. So the integral of a to the x dx is 1 over ln a to the x plus c. So to find the general solution of integral of 7 to the x, that's just going to be 1 over ln 7 times 7 to the x power plus c, following this formula right here. Now, this one right here, if f prime of x is equal to e to the x minus 2x squared, find the particular solution of f of x if f of 0 is equal to 4. So the first thing we can do is find the antiderivative with the plus c. So f of x is equal to e to the x minus 2x cubed over 3 plus c.
And we figure out exactly which c.
So now we have this general solution. We can plug in x is 0 and the f of x, the output's 4. So replace f of x with 4 is equal to, well, e to the 0 minus 2 times 0 cubed over 3, which is 0, plus c. 4 equals e to the 0 is 1 minus 0 plus c. So 3 is equal to c. Now we found the c value here from our condition. We can plug this back into f of x. So f of x is equal e to the x minus 2x cubed over 3 plus 3, because we found c was equal to 3. So this is your particular solution because they gave you an initial condition. Logarithms. Integral of 1 over x dx. The answer here is ln of absolute value of x plus c. If you remember all the way from Unit 2, the derivative of ln x is 1 over x, so the antiderivative or integral of 1 over x is ln x. So right here, an example, integral of 1 minus 5 over x. Well, the integral of 1 is just x, and then 5 over x is just 5 ln absolute value of x plus c. F prime of x. If f prime of x is equal to 2 over x plus 6 over x squared, find the particular solution here. So, this is a little tricky one. Only if the bottom is x by itself can you use ln of absolute value of x. If you have an x squared or like x to the anything else, that is going to be the reverse power rule, which we learned earlier. So f of x here is just equal to 2 ln of absolute value of x, and this is minus 6x to the negative 1 plus c. If you're confused about the minus 6x to the negative 1, if we rewrote it as 6x to the negative 2, now we do the reverse power rule. 6x to the negative 2 plus 1 is negative 1 over negative 1. So that's a minus 6x to the negative 1. Now we can plug in our particular, or our initial condition. When x is 1, f of x is equal to negative 7. So negative 7 is equal to 2 ln of 1 minus 6, 1 to the negative first, plus c. Negative 7 is equal to 2 times ln 1. Remember, ln of 1 is just 0, so this becomes 0 minus a 6, because 1 to the negative 1, that's just 1, plus c. So negative 1 is equal to c. Now you can plug the c back into the general solution here. So f of x is equal to 2 ln x minus 6x to the negative 1 minus 1. And that is your answer for this one. So, trig integrals. This is just going backwards from all the derivative trig rules we learned from before. Integral of cosine x is going to be positive sine x plus c. Again, if you take the derivative of sine x plus a constant, you get cosine x. Integral of sine x is negative cosine x plus c, because the derivative of negative cosine x is negative negative sine x right here. Integral of secant squared x is tan x plus c, because the derivative of tan x is secant squared x. And continuing right here, you have cosecant x plus c. Integral of secant x tan x is secant x plus c. Integral of cosecant squared x dx is negative cotangent x plus c. So some examples here. What's the integral of 3 secant squared x? Well, you have to remember this identity. Well, that's just 3 tan x plus c. This one right here, if dy dx equals 1 minus sine x, find the particular solution of f of x if f of pi is equal to pi minus 2. So we can first find the integral first. So if you integrate both sides here, kind of like that, right? Y is equal to, well, integral of the derivative, that's just y. Integral of 1, that's just x. The integral of sine x is negative cosine x. So a minus a negative cosine x, that's a plus cosine x plus c. This is our general solution. Now we can plug in our conditions. When x is pi, y is pi minus 2. So pi minus 2 is equal to x is pi. So pi plus cosine pi plus c. See that pi and the pi cancel out. So we have a negative 2 equals cosine of pi is negative 1 plus c. Add 1 on both sides. That gives you negative 1's equal to c. So you plug the c back into the general solution here. Y is equal to x plus cosine x minus 1. Here are some inverse trig derivatives here. These are derivatives here. So if you recall, d dx of arc sine of x is 1 over square root of 1 minus x squared. These are all back from 2.10. Derivative of inverse secant of x is 1 over absolute value of x, square root x squared minus 1. And the derivative of arctan of x, or tan inverse x, is 1 over x squared plus 1. So, the integral of 1 over square root of 1 minus x squared, well, that's just arc sine, or inverse sine of x plus c. Question 8. Integral of 1 over absolute value of x times the square root of x squared minus 1. That is just arc secant of x plus c. And again, we could have rewritten this as arc sine. The first one here is arc sine of x plus c, or this one as arc secant of x plus c. Secant inverse, arc secant, they're the same thing. These last two problems here are just additional techniques you can use to solve integrals. So if you have all this, right, you can rewrite this as each term on the top divided by x. So integral of 3x squared over x plus x over x minus 2 over x dx. Now if you simplify that, 3x squared over x, that's just 3x, plus x divided by x, that's 1, and you can't do nothing about this 2 over x. So this is nice now. So you can take the integral of each one of these individual terms. So that's a 3x squared over 2 plus x minus 2 ln x plus c. And if you went backwards, right, if you took the derivative of this answer right here, which is our final answer, you get what we have inside the integral on the line above. This one here, you can combine these expressions. So if you rewrite this, that's 3x parentheses x to the 1/2 plus x squared. And if you remember, if you have, well, 3x is the same as 3x to the first. And remember, if you're multiplying the same variable, you're multiplying them, you just add the exponents together. So that's going to be 3x to the first times x to the 1/2. That's 3x to the 1 plus 1/2, which is 3 over 2, plus 3x to the first times x squared, that's just 3x cubed. And then you take the integral of that. You're just using the reverse power rule. So 3x to the 3/2 plus 1, that's 5 over 2. And then divide that by 5 over 2. Plus, same thing, 3x to the 3 plus 1, which is 4, divided by 4. And don't forget the plus c when you have the indefinite integrals such as this one. If you have questions, please make sure to ask your teacher. Otherwise, you can go ahead and start the practice.